Hello, friends, and welcome to a lecture on numerical methods in Python. Today, we will learn how to solve a coupled differential equations. Now, such differential equations are a very frequent occurrence in science and engineering, especially chemical engineering, mechanical engineering. They are a frequent occurrence. Now, let's see what a coupled differential equation is, and they especially occur when you do dynamic simulation. So, let's have a look. It is solve the differential equation dx by dt is equal to minus 0.5x, dy by dt is equal to 3 by 2 0.5x minus 0.045y, and dz by dt is equal to 1/3 into 0.45y. Now, the interesting part here is that the change in x, y, and z depend on x, y, and the change of z depends on y. Well, here you can see here the change of y depends on x and y both, and the change of z here depends on y. Now, these are coupled. They cannot be all these differential equations. If you have to find the progression of x, y, and z with respect to time, you have to solve all the differential equations simultaneously. Now, how we have to solve them? Let's start by taking the initial values of x, y, and z as 3, 2, 1, and the domain of P is 0 to 19. So here what we do first is we import all the libraries. So let's start by importing numpy as np, then import matplotlib dot py plot as plt, that is for plotting, and from scipy.integrate import ODEINT. So these are the three necessary libraries that we have to import. The first one is a NumPy library, that is for arrays and mathematical functions. The second one is matplotlib. This is used for plotting. And the third one, of course, is for integrating. That is imported from scipy.integrate. The first thing that we have to do is define the system of differential equations in Python. Okay, that's the first thing we need to do. So let's go ahead and do it. That was, of course, M, and yeah, there we are. So let's go ahead and define it. We write define CDE coupled differential equations, and then we write variable, that is for the array of variables x, y, and z, and this is the independent variable, that is t. Then we write x is equal to variable 0, y is equal to variable 1, and z is equal to variable 2. Having done that, we define our differential equations. Dx dt is equal to minus 0.5 x, dy dt is equal to 3 by 2 0.5 x minus 0.45 y. And finally, dz dt is equal to 1/3. So that's 1 by 3, 0.45 y. And we return the values. So we return it as an array dx dt dy dt and dz dt. We are pretty much done with it now. So this is the way we have defined our system of differential equations in Python. Now what we have to do is we have to define the initial array. So the initial array is var 0. Now this is going to be equal to the initial values of x, y, and z, that is 2, 3, and 1. Having done that, we can test the system of differential equations by passing in the values of var 0 at 0. And we see that we get here the output, and this is a numerical output, so we can at least know that yes, all the three equations have been written syntactically correct and we are getting some output out of it. Now we start by solving the differential equation. So we write solution of the concentrations is equal to ODE int. Before that, of course, we have to define the domain of the function. That is, the domain here is time is from 0 to 19. So we have to create a domain for it. So we write t is equal to np dot linspace 0 to 19. We create 100 points, equally spaced points between 0 to 19. Now we can work towards the solution. So the solution concentration is equal to ODE int. Then afterwards we have CDE, that is, we input the function and the initial values of the variables and the independent variable, and we run it. So let's look at the output of. Now we get an array of values here. The first column is the value of x. The second column is the value of y, and the third column is the value of z. Okay. Now, if we want to view it column wise, all we have to do is put a square bracket, colon, comma, 0. This would give us the first column. Right. Now let's go ahead and plot it. So for that, what we do is we write plt.plot the independent variable, then the first dependent variable row, that is okay, then the second dependent variable row, and the third one. So we are done with the plotting, and this should give us the output, of course, of all the three variables. Okay, so it is not giving us for variable, it is giving us for variable 0. It is also giving it us for variable 1, and it is giving it us for variable 2, 0, 1, 2. Yes, it should give all three. So let's go back and check it once again. And let's see what is the reason. Okay. So let's check here. Where is the problem? Now let's check here. Are we getting all the three rows first of all? So let's do it here. Are we getting all the three rows? That is columns of values. So this is the column of value of 2. This is the column of value of column 1, and this is column 0. So this is column 0. Okay, so to plot it, we have to do this way, plt.plot. We cannot plot all three in one, so we have to write it as t, comma, my bad, 0, and copy down this command twice. And change the columns now. Here we put it column 1 and here we put it column 2. Now we are done, and this would give us the required output. Yes, this does give us the required output. There we are. Now let's put a grid on this. So we put grid plt grid grid, and let's name the labels. So we put plt.x label, and the x label of course is time in round brackets, so that is time. And of course the y label is values of x, y and z. So we put plot y values of x, y and z. We are done, and there we have our plot, which we can copy and put it in all presentations. Now it is the value of x, y and z, and this is time, and we have got a grid from which we can read the values. Okay, the results of the differential equation should be that at the ultimate time we should get z as 3, and this is what we get it, and x and y should go to 0. Yes, it has gone to 0. So that was all about how do we program and study differential equations, coupled differential equations using Python. That was the end of my lecture. Hope this was informative, and do keep watching. And in your comments, if you have any specific requirement on numerical computation methods, you want to study something, or you want to just know something how to do it in Python, do write it in the comments and I'll make it. If you find this lecture interesting, forward this link to your friends and do ask them to subscribe my channel. Goodbye, friends. Have a good day.